Hi, I'm Francesc Campoy, and this is Just for Funk. So welcome to the first episode of 2017. Today I'm actually still traveling. As you might know, I get to travel quite a lot, so it made recording this episode a little bit hard, but I decided that I wanted to release it on February 1st, and that's my goal, to release one episode per month. So every first day of the month, you should have, I hope you will have one new episode of Just for Funk. And that meant that today I'm going to be recording from a hotel room here in Paris. You can tell it's Paris because if you're able to see the temperature, it is 22 Celsius. So it is definitely not in the United States. We're using Celsius here, which is a nice temperature, by the way. No idea how much that is in Fahrenheit, but that is not important. What's important is that today we're going to be building something really cool. So I think it was 10 days ago, I was in Florence for a conference called GoLab, golab.io, you can check it out. And I went to a workshop where I learned how to build video games in Go. So that's what we're going to be doing today. I'm going to be building a game that I call Flappy Gopher, and I hope it's not registered brand or something, because I'm going to be using it anyway. And it's going to be, I'm sure you've all played Flappy Bird at least once. It's that little bird jumping around. We're going to build exactly the same thing. It's still going to be a bird because I'm not that good at drawing, and I cannot draw actually a gopher, even if my life depended on it. But we're going to be building all of that in Go. So that's why it's Flappy Gopher. And we're going to be using this library, SDL2, which has a very good binding for Go. So does that sound fun? Let's get started. Okay, so we're gonna start as always with a completely empty directory, and I'm gonna start using my favorite editor, which is Visual Studio Code. So let's create a simple function main in a package main that what's gonna do is gonna be using SDL. And since it's already installed in my machine, you can install it on everything. It's supported on Windows, Linux, and Mac, and it's actually very easy to install with Mac, at least. Just brew install, that's it. So pretty simple. I can do sdl.init, and that's gonna ask me what do I want to init, and I'm gonna say I want to init everything. That will return an error. So if that error is not nil, we should print something about it. We could do log fatal, but I actually prefer doing fprintf of the error. So saying something like could not initialize SDL, and that's the reason, and OSXC2, which is more like what people normally do. Oh, and of course that goes to std error. Once we initialize this, then the last step, so the opposite of initializing is calling SDL quit. And this should be done at the end of this program, right? But the best way to do it in Go is just simply putting defer, so we know that it will happen at the end. Okay, so now SDL is initialized. The next step is to create a window. So to create a window, we're gonna call something that it is not surprisingly named. It's called create window. But actually, we're going to also call create window and render. And the window is basically like the OS window that appears directly on the screen, right? And the renderer is the one that handles what appears in that screen. And we're going to need both. So I'm going to create them from the beginning. So the parameters for these, I already forgot. So let's see the documentation. So create window and render. And the documentation is there. So let's see the documentation. So create window and render gets the width, the height, the Windows flags, a window, and a renderer. A bunch of stuff. But I don't think that we need all of those. Actually, we just have the width, the height, and the flags. The width, we're going to say it's 800. The height is going to be also 600, why not? And then let's pass, so SDL, the flags, we're going to say that we want the window to be shown. And that will return our window, our renderer, and our error. Again, if the error is not nil, we should be doing that. So what I'm going to do is I'm just going to move all of these to need another function. So I'm just gonna call it run, and if the error is not nil, just do this. So it will simply print that error here. And now we can do func run that returns an error. We'll do return error f of that thing. So we're keeping the context, but also we're not repeating that error handling over and over and over, which will get really boring really fast. Could not create window. Window. And that is the error. There you go. Cool. And if everything goes fine at the end, we should return nil. Also, the same way we call SDL quit at the end of running our program, we should also destroy the window. And there's a window.destroy. Easy. And that will destroy the window and the renderer, because the renderer depends on the window. So you're basically destroying those in a like kind of waterfall way, which is pretty nice. Syntax error. There you go. Still not happy. R declare and not used. Yeah, we're not using R. So for now, I'm gonna do this thing, basically telling the compiler, know what I'm doing, don't worry. So it lets me compile. Okay, so let's try to run it. And I'm gonna do go run main.go. And that finished way too fast, but I feel like maybe it is because our program is so fast that we cannot even see the window. So let's do time.sleep for a second and run it again. There we go. Okay, you saw that. We got a window. Let me sleep for 5 seconds so we can see a little bit more. There you go. We got a window right in the middle of the screen for 5 seconds, and then it disappears. Cool. So we got that working. Yay. Next step is let's paint something on it. Okay, so what we're going to be painting first, which is, I don't know if it's a good idea or not, but we're going to start painting the title. We're going to try to write Flappy Gopher in the middle of the screen. And to do that, of course, we're going to need fonts. And to that, I'm going to bring a font that I had somewhere else. I'm going to copy. I'm going to create a directory called res for my resources. And I'm going to copy res fonts. And I copy from my previous version of these res font Flappy TTF to res fonts. Okay, so now here we have res fonts and Flappy TTF. And Flappy TTF is something that you cannot open because it's a font and it has a lot of things, but basically it's a font that we can use quite easily. You could use any other font, by the way. So now what we need to do is we need to first open a font. But before we open a font, we're going to be using a different library, which is TTF. And that also requires, it's actually TTF that comes from with SDL. So don't worry, you don't need to install anything else. But you're going to need to also initialize it. So let's do it here on the top, ttf.init. Will that work? TTF. There you go. That is sweet. Okay, so it's actually not called, yeah, it's actually called TTF. So it adds the alias name to the package. So I can call it TTF, which is what I want to call it, because no one would ever call it SDL_TTF. So that's cool. So let's go to the documentation for this library, actually. Okay, so the documentation for this library says that init returns an error. So we should handle it. So if the error is not nil, return an error saying that could not initialize TTF. And that is the error. And we should ttf.quit. There you go, at the end. Okay, so now our window is going to be open for 5 seconds, which is long enough to show some titles. So let's put all of this in a function, actually. So DrawTitle. And I still don't know what I'm going to need to return. What I'm going to need not to return, what I'm going to need to pass to that. So just going to do this, say that DrawTitle is a function that returns an error. And for now, it's going to return nil. Okay, so Next step is we're gonna call ttf.openFont. We're gonna pass the path, so that's gonna be res fonts flappy.ttf, and we're gonna pass the size. And I'm gonna try first with 20 and see where that goes. And if I'm not mistaken, that's gonna return open font. It's gonna return a font and an error. Okay, so font and an error. If the error is not nil, return error f could not load font. Cool. Now that the font is open, we can use it to we can do render UTF-8 solid. There's a bunch of different ways of rendering letters. We're going to be using the solid way of rendering it. I think that the only difference is actually the way it's going to merge with the rest, but I'm not an expert on this, and I know that solid works, so we're going to go with that one. If someone knows exactly how this works, that's cool, and please leave a comment. I'm always curious about learning more, but we're going to use this one. Okay, so render UTF-8 solid. That gets a string and a color. The string is gonna be the title. So Flappy Go. Let's not be loud. Flappy Gopher. There you go. And that's gonna also pass an SDL color, which it is not a color from the standard library. And I'm not very happy about that. And I'm thinking that I might send a pull request to this library so this type color satisfies the interface, so I could use any color I want. But for now, we're just gonna use that struct. So, and that was a pointer. No, it is not a pointer. Okay, so we're gonna pass an SDL.color, and R is gonna be, let's say we're gonna paint it red. So actually, no, let's say we're gonna paint it orange. So red is gonna be 255, green, it's gonna be, that is hard actually. Green is gonna be 100, so green is gonna be 100, blue is gonna be 0, and alpha is gonna be 255. To make it completely opaque, let's move that here. So that's gonna be our color, and that will return a surface and an error. Now again, if that error is not nil, we're gonna say that we could not render title. Otherwise, what we're gonna do is we're gonna get from that surface, we're gonna get what we call a texture. And so a surface is basically something that is sizeless, if that makes any sense. It's basically something that we're gonna adapt into a bunch of pixels, and those pixels are the texture, and then we're gonna copy that texture into our screen. So to do this, to create the texture from the surface, we're gonna need the renderer. So I'm gonna need to pass it. Let's call it here. It's an SDL.renderer, and we're gonna need to pass it here. And since now we're using it, we can get rid of that line. Oh, not there, here. Okay, so now we're getting the S, and we're gonna do the renderer. We're gonna create a texture from a surface, and that function there, create texture from surface, receives a surface. That's pretty simple, and returns an error, and a texture and an error. If the error is not nil, return could not create texture. Otherwise, we now can copy the texture to our render. So we have copy that receives a texture, and then two rectangles. The first one is the source, so what part we're gonna get from the image, and we're gonna get all of it. The second part is on where in the destination we want to print it. So do I want to get all the window, or do I want to get something centered? And then I actually forgot what is the last one. So no, that's it. So there's the texture, the source, and the destination. And if we look at the documentation, If null is the source, we use the entire texture. If null is the destination, it will render in the entire target. So we can try with null. So we're gonna copy that texture into null, and that will return, let's see, an error. So we're gonna say could not copy texture and otherwise return nil. Okay, so let's try to run it, but before, let's make sure we're actually releasing all the things that we should be releasing. So if we open the font, we should close it at the end. We created a surface, and we should, I think it's called free, we should free that surface. Similar for the texture, we should destroy it, and we should call r.present at the end and r.clear at the beginning. So that's going to clear our buffer and then present it. So we're gonna clear a buffer, paint on it, and then put it on the other side. And even with all of this, there's actually another bug that let's say if you can see why this is not painting anything. See, 5 seconds, it doesn't do anything. It is actually because I'm kind of dumb sometimes. We're sleeping 5 seconds, then painting something as we're closing the window. So that's not gonna help. So we should return nil here and try to draw the title. If the title didn't work, we're gonna return an error saying could not draw a title, and just return it. And now, there you go. That makes way more sense. And that is actually pretty cool. I like it. Okay, so now we have a window that I'm gonna do it again because I like it. Okay, Flappy Gopher, boom, done. That is pretty cool. Okay, so the next step is going to actually start drawing stuff that is not text. We're gonna try to draw the background. So the background is gonna be a bunch of images. Well, actually just one image. We're gonna have then a bunch of images for the Flappy Gopher, Flappy Bird moving its wings. So we're gonna have 4 different frames for that. And then we also have pipes and stuff. And all of those are gonna be PNGs that we need to load and then display and rotate and move around. That's pretty much all the things we need to do now. So let's get started with that now. What I'm gonna do first is I'm going to, as before, I'm going to get all of those images that I had on my resource directory on my previous version. I'm gonna move them to the new one. So let's do simply move everything from Flappy images to res images. And now we should have a bunch of images. So we have the background. It said that you cannot see it. So let me open it. And I think it's kind of cool to see. Okay, so we have the background. Then we have a frame, another frame, another frame, another frame. So if you move them really fast, it kind of looks like it's flying. And then we have the pipes. So let's start by painting the background into the background, which is kind of obvious, right? So we're gonna need to load a different library, which I'm gonna call image, img, and it's under SDL image. So yeah, again, this is an package alias, and I'm using that. So instead of using whatever the name of this package is, I'm gonna just call it img, which is, in my opinion, better. So okay, so we're gonna draw the title, wait for 5 seconds, and then draw the background. And so we're gonna need the render as we did before. I do not need to pass that there. And if error is not nil, then we will return the error. Could not draw background. And finally, we're gonna wait for 5 seconds again. So that should paint our title, leave it there for 5 seconds, paint the background, leave it there for 5 seconds, and then finish the game. So let's write that. Draw background with given a renderer and returns an error. We're gonna do first r.clear, and at the end we'll do r.present as we did before, because we want to clear everything and then present what we painted in the middle, and now we need to paint something in between. So what are we gonna do? So we're gonna do image. That went away because I did save and I was not using it yet, so Go Imports got rid of it, which is totally normal. I will not complain about that. I love Go Imports no matter what. Okay, so we're gonna do load texture. And load texture, given a render and a file, will just create a texture directly. So the file is gonna be res images background.png, and that will return a texture and an error. If that is not nil, we say that could not load a background image. Otherwise, we will, as before, we'll copy that texture into the renderer. So r.copy and the texture, and we're gonna use nil again. As before, this returns an error, so we should check that out. If there is no nil, I just write it so often that write it twice in a row. So if the error is not nil, we will return an error saying could not copy background. Okay, let's make sure that we do t.destroy at the end because we're done with that. We need to pass the renderer, and we have that, and everything looks good. So let's try to run it. Go run main.go. So we get 5 seconds of Flappy Gopher and 5 seconds of background. Cool. Okay, so that was easy. Next step. Okay, so before we continue, I've been actually saving all of this using Git. And right now I checked at it and I did git status, and it says there's all of those .ds store, which I do not care about and should not be part of my repo. So what I'm gonna do is I'm gonna create a new file. I'm gonna call it git ignore, and I'm going to simply say whatever you find that is called ds store should be ignored. And now if I could do git status, all of those are gone. So now I can do git add all of this. Git status should show me all of the images, and git commit. I'm gonna say background painted for 5 seconds. Not in French. And not git push because I'm still not open sourcing this soon though. So the next step is I want to paint the bird, and to do that, basically the bird, what it's gonna need is we're gonna paint the bird, and every single time we paint it again, we're gonna paint a different frame. So we're gonna iterate over frame 1, 2, 3, 4 continuously until we basically see the bird flapping its wings. So let's try to do that, but let's think about how we want to do it. We're gonna need to move a bunch of things all the time, right? So we're gonna have a given frames per second, which actually I'm just gonna go for as much as possible and see how that works. If that works, well, why not? But the important thing is we're gonna try to paint all the thing every time. So the background, we paint the background first, then we paint the bird, and then the pipes and all of those things and whatever we have, and then we present that. And then we clear again, and then we paint the background again. So we're gonna do everything from scratch over and over, but we do not want to load all of the images every time. So what I'm gonna do is I'm gonna create this thing that I'm gonna call the scene. And the scene's gonna have first one method, which is gonna be probably a builder, like new scene, that's gonna load all the images that we need. And then it's gonna have a loop that's gonna basically paint the current position of the scene on the map. And then it's gonna have destroy, that's gonna destroy all the things that it had used before. So let's do that now. I'm gonna move it to a different file for the sake of clarity. So scene.go, it's gonna be, nope, package main. I'm gonna have my type scene, which is a struct. And for now, it's gonna have the background. So that was an SDL.texture. And when I do new scene, what it should do is it should pass the render, SDL.render, and it's going to return a pointer to a scene and an error. So, whoops, we're gonna move all these loading side of this into the scene. So it's gonna return, if everything goes well, it's gonna return a scene where BG is the texture and no error. Otherwise, it's gonna return nil and that error. There's a problem here. Image is not defined. We're gonna need that. So image is gonna be here. Cool. Then we're gonna have our method scene paint, which is this. So func scene paint, giving a render again. We're gonna need it too here. It's going to return maybe an error, and that's going to copy, but also it's gonna do the clear and the present. And we can do it here. We can do it at defer, why not? Actually, this is gonna be called very often, and defer is not the fastest thing, so just in case, I'm gonna move it to the end. It's actually not that hard. And return nil. Okay, what's going on? Oh, so what are we painting here? We're painting the scene background. Okay, and finally we're gonna have one last method, which is gonna be destroy. For this one, I do not need anything. What we're gonna do is bg.destroy. Just gonna call that function. So now our draw background is not needed anymore. What we're gonna do is we're gonna create a scene, new scene, given the render. If the error is not nil, we're gonna complain. Otherwise, we're gonna do s.paint, and we're gonna paint it. Then we're gonna sleep for 5 seconds, and we should do defer s.destroy. So this should do pretty much the same thing. So let's just run it and see if that actually works. New scene, undefined. Oh, I cannot do that anymore. So I'm gonna do go build and run Flappy Gopher from here. Okay, so we get the screen and we get then the background and we're all good. So we have pretty much the same code, but we move the code to that scene that has the 3 methods that we're gonna be adding stuff to. Okay, so there's a couple of things that I failed at. One of them is I'm sending this message saying could not draw background. That's not what we're doing. Could not create scene. But even more important is the fact that I'm not checking the error in that paint, and we should always be checking errors. So that I'm gonna return error f could not paint scene. There you go. So the next step is let's just paint one bird. So how are we gonna do that? We're gonna add that here. So bird's gonna have also a texture, and we're gonna need to load it. So we're gonna do something similar to that. So it's gonna be, actually, let's use the same one. So that's gonna be, no, we cannot use the same one. So that's gonna be bg, and bird. It's gonna be bird frame 1 png, and we're gonna pass it also here bird, whoops, bird. Okay, then we need to paint it. So in a similar way, we're gonna do paint of that bird, and we're gonna need to paint it somewhere. So that is where things start to get interesting, right? The bird should have a position. We don't know exactly which position we're gonna have yet. So let's try to paint it somewhere in the middle of the screen to the left. So that is something that's gonna be around. So we had rectangle, it's gonna be SDL.rectangle. The height's gonna be, so this is actually the size. What is the size of the bird itself? It is 50, 43. So 50, height is gonna be 43. Then we're gonna have the X and Y. So X, let's say that X is gonna be 10 and Y is gonna be, so we had 600 for the height of the screen. So this could be 300 minus 43 divided by 2. So our bird will actually be centered in the middle of the screen. And we're not using it, so we should be using it here. And we're painting the bird, and that might work. So go build, and Flappy Bird, Flappy Gopher. Okay, I will cut this to only 1 second because, you know, we don't need that anymore. Whoops. Okay, could not load bird frame 1.png. Frame underscore 1. Okay, frame underscore 1.png. And let's change that so the title only displays for 1 second. So that's gonna be that weight there. Okay, so now we have 1 second of title. Look at that, the bird's right there, but it's not falling or anything, but it's fine. Now what I want to do is I want to animate it. So what we're gonna do is, rather than having one texture, we're gonna have a slice of textures. Okay, and we're gonna need to load all of them. We're gonna have for I equals 1 and, well, I up to 4, we're gonna load an image, and that's gonna be the name of the image. Path is gonna be sprintf of that thing, and a number that's gonna be I. We're gonna load that path. If something fails, we fail. Birds is slice of textures, and we're gonna add birds. We're gonna add bird to birds, and then we're gonna use birds and birds and birds. Birds the word. That's a great Simpsons episode, by the way. And that's gonna be birds. So what we're gonna do is we're not gonna paint all of them. What we need to do is every single time paint is called, we should paint a different one. So what I'm gonna do is I'm gonna add a time. So it's gonna be an int 64, and that's gonna be an int 64. Actually, we could do an int. Let's do int 64 so it's bigger. So what we're gonna do here is we're gonna say, when we call paint, that's going to add one more. So s dot t plus plus. Let's call it time. Time. So we increment time every single time we paint something. Okay, so what we're gonna do is the bird we're gonna paint is gonna be position here of the index, and actually let's call it I, why not? And the I is gonna be chosen with s dot time. So, whoops, s dot time modulo length of s dot birds, and time is an int 64. So we're gonna need to do that. Actually, let's just put it int. We could have issues later on, but you know, this game is kind of a very, very simple game, so it should be fine. So okay, so we're gonna paint a different one. Okay, so let's try that. 1 second. Oh, doesn't work. Why? Oh, it's not working because we're just calling paint once, right? So now what we want to do is we want to go and we're gonna say that when we call paint, we're gonna do func.scene run. That's gonna return a channel of errors. And follow me here. So what we're gonna do is we're gonna be able to call run in a different Go routine, right? So this is gonna create a channel of errors, and this channel that we're gonna be able to read from, and then it's gonna do in a different Go routine. It's gonna do a for loop forever, basically going and painting. So painting the renderer. So I'm gonna need the renderer here too. So s.paint r, and we're gonna return rc. And now if painting fails, we're gonna send the error into the channel, and that's pretty much it. So now we should be able to come here and do select, and if we get something from s.run, then we know that something failed, so we can do could not paint scene, because we know that that's actually the only error we're gonna get. And if the other case, we're gonna get time dot after 5 seconds, and that's gonna be simply return nil. Whoops. Okay, and we need to pass the render. We should also be able to pass a way to stop the renderer later on, but actually let's do that. So quit. Quit. It's gonna be a channel of nothings, and we're gonna defer closing quit. Actually, you know what? Instead of doing that, we're gonna do a context. So context background and context with cancel, and we're gonna defer calling that cancellation, and we're gonna pass that context. So now after 5 seconds, we will actually call cancel, and that cancel function will cancel the rendering. So we need context here, context, and we're gonna do either select here too. So we're gonna try to get context done. If it's done, we're gonna return nil, and we're gonna be closing that channel anyway at the end, just in case. So we'll get a nil error. And if the other option is default, we're gonna actually return nil. Oh yeah, that is return. Yeah, we don't return anything, so we just exit that loop. Okay, so now what we have is our scene, and the scene is running in different Go routine, and then we have the main Go routine that's just waiting there, right? So what we do is we start the scene and with a context. That context will be done whenever the scene should finish. And then on the other side, also we're getting that channel, and that channel is the one we're using. Sorry, that channel here that we're using directly to receive stuff from. And that channel will either be closed and return nil. So we should check for that actually. So if the error is not nil, well, we could just return nil and return that error. Why not? Okay, so either the scene fails or finishes for some other reason and returns something here, which could be something, but we will report that, or after 5 seconds, we will return from this function, which will call cancel and will stop the other coroutine. So we are actually freeing everything correctly. And this doesn't work. Sad. Why doesn't this work? Oh, because the first should be here. Otherwise, we're closing the channel as soon as run returns, which is way too early. We want to close the channel only when this go routine finishes. Okay, let's try that again. Okay, so, oh, you see that? That is kind of crazy. We're moving way too fast. Poor bird. Okay, so we're gonna need to slow it down a little bit. And now it's actually kind of easy, because what we need to do is on this for loop, we could do time.tick, time.millisecond for range in time.tick, time.millisecond. So every millisecond, we're going to either verify if we should be done, or if we should be painting something else. Let's try if that slows it down a little bit. I think it did. So let's do 100 milliseconds. There you go. Now it's actually moving at a decent speed. This I like. Okay, so that's the animation we're gonna have, which is 100 milliseconds, which is 10 frames per second, which is actually not that much. I'd say we should maybe go with 100 frames per second. I guess that sounds about right. But at the same time, what we're gonna do is we're gonna move these only when we go over 10. So we're actually gonna divide that first. So we'll animate the bird only 10 times per second, but if we want to animate anything else way faster, like the pipes or whatever, we could still animate those up to 100 times per second, which sounds about good. Okay, so I thought this episode was gonna be around 30 minutes, which is what I normally try to go for. And as you can see down there, it's been already 43 minutes of me talking all the time and coding. So I've decided to stop this episode here. But there will be a second part if you tell me to. So let me know in the comments. Do you want me to continue doing this? There's all the pipes, there's more concurrency. How do you handle when there's more than two go routines right now? Right now we have two. So once we have more, and how do you handle the pipes hitting the bird, etc.? There's gonna be like concurrency and mutexes. And I feel like this is an interesting project because there's a Flappy Bird flying around, which is cool. But at the same time, I don't know, maybe I'm just a little bit of a geek guy that loves weird stuff. So let me know in the comments. Let me know if you're enjoying this and if I should continue or if I should do something else. Anyway, as always, thanks for watching and talk to you soon.